Hi everyone, welcome to Mr. Wagid's math class. Remember last time we talked about the Pythagorean theorem that says if you have a right triangle, then a squared plus b squared equals c squared. This is the Pythagorean theorem that we use to find the missing side of a right triangle. Here's how we proved it. If you have a right triangle, we proved that if I square one side of that triangle, add it to the square of the other side of the triangle, will give you the square of the longest side of that triangle, which is the hypotenuse. So let's review what we already learned about the Pythagorean theorem. So here's a right triangle. A right triangle has three sides, and each side has a name. Leg A, leg B. It doesn't matter which side we name it, leg A or leg B, as long as those two sides, they make the 90-degree angle. The third side is called the hypotenuse, which is C. I know which side is the hypotenuse because it's always the longest side of a right triangle, and it's always across from the 90-degree angle. Now, what the Pythagorean theorem says, if I square side A, add it to the square of side B, will give me the square of the longest side, which is the hypotenuse, which is C. We will use this equation to prove if a triangle in fact is a right triangle. And we also going to use this equation to come up or drive different formulas that we will be using through the lesson. So now how can we use the Pythagorean theorem to prove the triangle is in fact a right triangle? This is what's called the converse of the Pythagorean theorem. That says if the relationship between the side length is true, which means if a squared plus b squared does in fact equal c squared, then that triangle is a right triangle. Now let's use the converse of the Pythagorean theorem to prove if the triangle is in fact a right triangle. And I'm not drawing the triangles because I do not want you to assume that the triangle is in fact a right triangle just by looking at it. So remember, a triangle has three sides, two of them are the legs, and one of them is the hypotenuse. Here's an example. The first one is 18 feet, 12 feet, and 24 feet. Write the equation first that says a squared plus b squared equals c squared, but I'm checking to see if that statement is in fact true. So there's a question mark on the equal sign. The first number that you need to think about is the biggest number, because the biggest number represents the longest side of the right triangle, which is the hypotenuse. The biggest number is 24, so that would be the hypotenuse, which is C. So put 24 squared, that's the first number to replace in the equation. Now bring the equal sign. It doesn't matter which side is A, which side is B, because those two are the legs, they make the right angle. So let's say B is the 12, and you need to square it, plus A is the 18 feet, and you need to square it. Now evaluate till the end. 18 squared means 18 times 18, which is 324. Bring the plus sign down. B squared is 12, and 12 squared means 12 times 12 is 144. Bring the equal sign down. 24 squared means 24 times 24, which is 576. Now, still you're checking, so you still have the question mark on the equal sign. Combine like terms on this side. 324 plus 144 equals 468. Bring the equal sign down and the 576 down. Does 468 equal 576? No way. This is not a true statement. Therefore, the triangle isn't a right triangle. Now here's the other example with side lengths of 1.25, 1 millimeter, and 0.75 millimeter. Remember to write the equation, a squared plus b squared equals c squared, with a question mark because you're checking to see if that statement is true. Now, the first number to replace, always the biggest number because it is the longest side of that triangle, which is 1.25, the hypotenuse, and square it. Now, it doesn't matter which one is A, which one is B. So I would say B is 1 squared plus A is 0.75, but you need to square it. Now evaluate those numbers. 0.75 squared means multiply the number by itself, 0.75 times 0.75, which gives you 0.56. Bring the plus sign. 1 squared means 1 times 1, which is 1, equals 1.25 squared is 1.56 because 1.25 times 1.25 is 1.56, again with a question mark. Now combine like terms. Add 1 plus 0.56 is 1.56. Bring the equal sign down and 1.56 down. Does 1.56 equal 1.56? Yes. That means the triangle is a right triangle because squaring the leg added to the square of the other leg gave you the square of the longest side, which is the hypotenuse. Now we will use the Pythagorean theorem again to find the distance between any 2 points on a coordinate plane. Let's see how that works. How long is that line AB? First of all, I will make a right triangle. So draw a vertical line, AC, and then a horizontal line, and close that triangle to create a 90-degree angle. Now you have a triangle ABC. This side, CB, we will name it leg A, and side AC, we will name it leg B, and the green line, which is the slanted side, would be the C or the hypotenuse. How can we use the Pythagorean theorem? First of all, let's find how long each side is. Side CB, which is leg A, since it's the horizontal line, then it's a difference between the x's. Let's say B is x1, y1, and C is x2, y2. I don't know what the numbers are. Since it's the horizontal line, then we subtract the x's, or the difference in the x's gives you the length of CB, so x2 minus x1. Now I need to know how long is side AC, which is the other leg of this right triangle. Since it's the vertical line, then it's the difference between the y's. So let's this time name A x1, y1, and keep C as x2, y2. Find the difference in the y's. y2 minus y1 will give you the length of that side or that leg. Now side AB is the hypotenuse. We'll keep it the way it is because that's what we're trying to find. Now write the equation. Now I rearranged it. I wrote C squared equal A squared plus B squared, which is the same thing. Now replace the numbers. I know C squared is side AB, but I need to square it. A squared is side CB, and I need to square it. B squared is side AC, and I need to square it. Now let's replace what we know. We don't know the numbers, but we do know the difference between the x's and the y's. But this time, because I'm trying to find the distance between A and B, which is the hypotenuse, I will replace that with the letter D for distance, but still I need to square it, equals CB is the difference in the x's, needs to be squared, and the length of AC is the difference in the y's, and I still need to square it. Now square root both sides to get rid of the squaring. So you square root D and you square root all this side. Remember, squaring and square root, they cancel each other. So you end up with D, which is the distance, equal the square root of the difference in the x's, x2 minus x1 squared, plus the difference in the y's, which is y2 minus y1 squared, because this is leg A squared plus leg B squared. Now let's review the distance formula, which says D equal the square root of x2 minus x1 squared, which is leg A of a right triangle, plus y2 minus y1 squared, which is leg B in a right triangle. Therefore, the D is the hypotenuse of a slanted side. So you can use this equation, which is the distance formula, to find the length of any line or the distance between any two coordinate pair on a coordinate plane. Now we will use the Pythagorean theorem and the distance formula to prove if this red triangle is in fact a right triangle. Watch, I can't count spaces to know how long each side is. So what do? We use the distance formula to find the side length. But let's name each side. Side AB will name it D1. Side BC will name it D2. Inside CA, we'll name it D3. So D for distance. So we will be using the distance formula to find the length of each side. D to find D1, which is the equation. Now on the side, please write the coordinates for B and A. Name the first one x1, y1, and the second coordinate x2, y2. Now replace the numbers in the equation. X2 minus x1 squared is 5 minus negative 6 squared, plus 9 minus 6 squared. Make sure it's all still inside the square root. Now evaluate. 5 minus negative 6 is 11, but still I need to square it, plus 9 minus 6 is 3, but I still need to square it. And remember, it's still under the square roots. Now evaluate again. 11 squared is 121. 3 squared is 9. Now add them, equals 130, but it's still under the square root. So make sure to keep it under the square root till the end. If you do want to evaluate that, go for it, but I will explain to you why not to at the end. Now I need to find how long is side BC, or the distance between B and C. Again, use the distance formula to find what D2 is. So which numbers to use? Write the coordinates for B and C this time. Name the first one x1, y1, and the second coordinate x2, y2 to know which numbers to replace in the equation. x2 minus x1, so negative 2 minus negative 6, but make sure it's squared, plus subtract the y's, which is negative 8 minus 6, and you need to square it. Again, it's still under the square roots. Now evaluate. Negative 2 minus negative 6 is 4, still squared, plus negative 8 minus 6 is negative 14 squared. Now, because the numbers are negative, it doesn't make a difference because you need to square it. 4 times negative 4 is positive 16. And negative 14 times negative 14 is positive 196. So if you get a negative number before squaring, it's okay. Equals the square root of 212. Again, remember, it's still under the square root. Now I need to find the other side, or the third side of that triangle, which is D3. Use the distance formula. Write what the coordinates are, C and A. Name one x1, y1, and the second coordinate x2, y2 to know which numbers to replace in the equation. x2 minus x1 squared is 5 minus negative 2 squared, plus, subtract the y's, 9 minus negative 8 squared. Now evaluate. 5 minus negative 2 is 7, but still you need to square it. And 9 minus negative 8 is 17. You still need to square it. 7 squared is 49, and 17 squared is 289. Add them is 338, but keep it under the square root. So remember, they are still under the square root. Now that we know how long each side is, and we wrote them on the triangle, let's prove if it's in fact a right triangle using the Pythagorean theorem. A squared plus b squared equals c squared, with a question mark to make sure that this side does in fact equal that side. We always start with the longest side, which is the hypotenuse. So the biggest number is the square root of 338, so I know the hypotenuse is 338. Remember, I kept it in the square root, under the square root, because I need to square it. Now, which side is A, which side is B? It doesn't matter. So let's say side B is the 212 and you need to square it. Side A is 130 and you need to square it. So that's why I kept them under the square root, because now you know that squaring and square root will cancel each other. Because squaring and square root cancels each other, you end up with 130 plus, again, squaring and square root cancels each other. Bring the 212 down, equals, again, squaring and square root cancels each other. You end up with 338. You are checking to see, so there is a question mark on that equal sign. Combine like terms, you get 342 equals 338, but that's not a true statement. Therefore, the triangle is not a right triangle. Today, we were able to learn the converse of the Pythagorean theorem, that if we can prove a squared plus b squared equals c squared, then the triangle is in fact a right triangle. We also use the Pythagorean theorem to come up with the distance formula to find the distance between 2 points or the length of any line on a coordinate plane. We use the distance formula and the converse of the Pythagorean theorem to prove if this triangle is in fact a right triangle. If you have any question, please write it in the comments below. I truly appreciate your subscription and liking my videos. You guys have a great day. See you next time.